Good afternoon. Welcome to the final FAIR implementation workshop of the series. Today, we're going to be speaking about measuring FAIR4RS application of the F-UJI tool to the Ersilia Model Hub with my colleague Gemma Turon, who's going to be presenting today. So as I said, this is the final meeting of the FAIR implementation workshop series. Over the series, we've aimed to help three key stakeholder groups, research performing organizations, repositories and data service providers, and national level initiatives to become more familiar with FAIR enabling tools, approaches, and methods. Each workshop demonstrated and gave an overview of a specific FAIR enabling activity, shared information on recent developments, both from within FAIR Impact and other initiatives, as well as offering examples of good practice, practical tips, and recommendations. So just a bit on FAIR Impact itself. So FAIR Impact is funded under the European Commission Horizon Europe program and is one of the infra-EOSC projects. The project builds on the work of the Horizon 2020 FAIR project and is a coordination and support action focusing on expanding FAIR solutions in Europe. The project itself has 28 partners from 10 member states and the UK. As I mentioned, as the final FAIR implementation workshop series today, the project is actually concluding in May, having started in June 2022. So essentially, FAIR Impact, this project worked to support the vision of a European open science cloud where data can be shared and reused. Our work focuses on identifying current and emerging tools, methods, and approaches, supporting their adoption. A key aim in the project is to help ensure that useful resources developed by our community of practice can be adopted by others, something Gemma is going to expand upon in her presentation. So I'm just going to hand over to Gemma Turon, Ersilia's co-founder, a software sustainability fellow, and one of the main developers of the Ersilia Model Hub. Gemma, welcome. Thank you for joining us today.
Thank you, Al. So let me share my screen. Okay, does this work?
Yes, I can see the slide now.
Perfect. Hello, everyone. Thanks for joining in. I appreciate online workshops are not the most exciting thing to attend to after so many years. But thanks so much for making this time. I'm happy to talk today about how we have implemented fairness principles to our main open source platform for research into infectious diseases, the Ersilia Model Hub. Partially the work that we did during the FAIR Impact program last year, but also other things that we've learned along the way. So I hope you can take something useful from this talk and feel free to drop in any questions and we'll tackle them at the end. So just a bit of an agenda, because I'm sure not everyone here, I hope, is that familiar with Ersilia's work. I'm going to give a bit introduction of this research organization, which is a bit unique in between academia and nonprofits. I'm going to discuss why we started getting worried or interested in improving our FAIR4 software practices, and how we've used F-UJI and other tools to basically try and start improving our software and what we envision for our next steps. So with that, I'm happy to introduce to you to the Ersilia Open Source Initiative, which is a nonprofit organization working to reduce inequalities in global health. So we basically equip and provide and equip laboratories in low and middle income countries with artificial intelligence tools for infectious disease research. We work in the global health area. So unfortunately, there is still a huge inequality in the field where 6 of the top 10 causes of death in low-income countries are still due to infectious diseases, and those countries produce less than 5% of the world's research. So basically, the diseases that affect their populations are systematically neglected, underfunded, and under-researched. Indeed, only 15% of the drugs that are in development in the world today are targeting infections, which include major diseases like COVID, malaria, tuberculosis, HIV, but also more minoritary and neglected tropical diseases. So what we are doing in the face of this huge disproportion, what we focus on is on bridging the gap for drug discovery, for finding new, more efficient treatments for these diseases using artificial intelligence. Why artificial intelligence? Well, because it's cost effective. So we work mostly in laboratories with low resources, both computational and experimental. So anything that we can do to speed up the research has a great impact. It's fast to implement. It's much easier than bringing expensive laboratory equipment or other kinds of interventions that you can do in research. It allows us to reuse methods, existing methods that have been developed for other research fields. For example, cancer, Alzheimer's, and other diseases for which there is more data. And of course, we believe this is an unprecedented opportunity for low-income countries, which have a currently low to no access to all these new AI developments, and that could be really transformative and impactful for their research ecosystems. So the work of Ersilia is divided in 3 pillars. We'll be mostly talking about the first one today, which is the development of free and open source tools for researchers. Everything we do it publicly, real time. It's open access under open source licenses, and it is not patented and will never be. We then implement the software that we develop through scientific collaborations with in-country researchers, meaning we look for scientists working in these low and middle income countries, mostly in Africa, and we try to partner with them to offer our tools and support their research projects with this AI expertise. And finally, to make this collaboration sustainable in the long term, and we basically include a component of training and capacity building, especially on data science and AI, for the researchers that we work with in these in-country institutions, with the idea to start growing local AI hubs that can basically self-sustain using Ersilia's tools and other tools, and start spreading the use, more broadly, the use of these tools for especially academic researchers. Also, in order to maintain everything that we do, we need to focus a lot on making our tools usable in low resource settings, meaning poor computational environments, low internet connectivity, and so on and so forth. And I would add here, we need to focus a lot on making everything we do really fair so that it can be reused by anyone, even with someone without that much expertise. So our goal basically, just to put it very simply, is to provide ready-to-use AI models. When we talk about AI models, there is a lot of things that happen under the hood. So there is the collection of raw data. This data needs to be processed. The model needs to be trained, which is only one step of the process, because once the data is cleaned and the model is trained, we still need to test it, to validate it, and finally, hopefully, validate it externally in the lab, if that's at all possible. But what is missing from most of the academic software today and research software is this external layer of deployment, which to us encompasses not only making the models easily to use, but also easy to maintain so that they will persist in time. So that any researcher can come with a question, for example, a drug, select the model of relevance to their disease area, their research project, etc., and obtain a prediction, for example, the target of this drug. Yeah, so we are collecting all these models. We have different kinds of models in our hub, in this Ersilia Model Hub that we are talking about. We first have models that we collect from the literature. So we do an activity that is already aimed at making those models more fair. So basically, we take code that has been lying there, published, but many times not updated and not maintained by the original authors. And we basically implement it within the hub so that very easily a scientist can now come with a question, for example, a drug, and get whether a prediction, in this case, whether this molecule is an active antibiotic or not, according to this deep learning model developed in 2020. We also scourge the literature and the databases to obtain good data on which we can train our own models and deploy them in our platform. In this example, a large open source drug discovery effort for antimalarial drugs. So we take this data, we build a model, and then with this model, researchers can come and make predictions. For example, if this molecule would be an active or inactive antimalarial drug. Finally, we also work in collaboration. So we work with scientists, mostly across the African continent, and we try to build models together based on their data and adapt it to their needs. In this case, for example, with the University of Wales, we work on natural product-based drug discovery so that they can predict better the potential activity of those compounds against infectious diseases, and also with a strong focus on viral diseases. So these are the three types of models that you can find in the Ersilia Model Hub. We currently have about 170 models available. So this is how the hub looks today. You can simply browse it and see how many models, which models are of interest to your research. And we envision the hub as a circular way of implementing AI in academic and nonprofit research. First, scientists can browse the hub, and we aim to achieve up to 500 models in the next couple of years. So really offer a wide selection of models that covers different needs from the researchers. Then these researchers can run these models. There is a simple command line interface to obtain predictions for up to millions of molecules. They can also access custom online deployments that at the moment are made on a use cases with partner institutions that we aim to provide more widely if we obtain sufficient financial resources for online maintenance. We are developing, this is something that is under development, and a large language model that would allow us to integrate all these steps in a way that is much easier for our users. And then finally, of course, we invite all scientists and computer biologists to build and contribute models to our repository, as this is a truly open source effort. This last point, this fifth point, happens in a semi-automated way so that we have become quite efficient in incorporating open source contributions. So basically, anyone can open what we call a model issue, so a new idea for a model incorporation, be it starting from a data set or from a model that is already published. We engage in some discussion. We may discuss whether this model fits within the Ersilia Model Hub scope or whether the data is good enough, etc., etc. Once it is approved, we start an automated pipeline that basically builds a new model repository, obtains some basic metadata for the model, and then allows the contributor to fork this repository, work on it at everything that is necessary. It's all templated, so it's quite easy to follow. And once the contributor feels this is ready, they can open a pull request, which goes through several layers of automated testing. And if all these layers pass, there is a final clerical review by the Ersilia team, and the model is released and available through the Ersilia Model Hub for the model contributor and anyone else that wants to use it. This has been developed with the help of many organizations, including GitHub Atlassian, Outreach interns, and Harvard University volunteers, and it continues to grow and improve to basically make our tools more accessible to any contributor. So just before we go really into the FAIR principles, especially FAIR principles for research software, let me give you an overview of who do we work with on a daily basis so that you understand why FAIR becomes so important to us. So we are a fairly small team. We are currently 4 full-time people. We also have master's students, undergraduate and graduate interns, and a lot of volunteers that contribute to our cause. And this team interacts on a daily basis with scientists, other scientists based in the global north. Ersilia's offices are currently in Barcelona, I didn't mention. So we work with other scientists here that basically expand our capacity, experimental capacity. They also provide computational resources, data sets, and so on. We most importantly partner with African researchers. So I'm just listing here a few of our partner organizations with whom we engage in research and training. We also benefit from partnering with organizations that we call data donors. So these are typically larger nonprofit organizations or even for-profit companies that have accumulated wealth of data on, in our case, drug discovery, and are willing to share this data with us so that we can build new models. And then finally, we work with software engineers and big tech. So we are also very lucky to count on the support of many volunteers that are organized by these large corporations that bring in a software engineering expertise that otherwise as academic scientists we would not be able to obtain, and that has allowed us to really reach a more fair level in our platform. So just before we go into looking into detail in the F-UJI tool, I wanted to stop a bit and think about what is FAIR for research software and why it is important to Ersilia. So research software is basically a digital object as defined by the NIH. Is the source code, files, algorithms, scripts, the computational workflows, the executables, everything that is created during the research project or for a research project. So for example, everything that is in the Ersilia organization GitHub repository is considered a research software because everything is done with a research purpose and it's mostly just code, workflows, and executable files. So all these are called digital objects, and what people started to realize, so the FAIR principles came about in about a few years ago, and then people started to realize that this did not only apply to data, which was the original intention or the original focus of the FAIR principles, but basically any digital object, which today most importantly includes research software, which is becoming a prevalent and much necessary tool for performing research. So if we look at the origin of the FAIR principles, let's focus on data. We have 4 FAIR principles. So if we think about data, in a very basic level, is the data findable? So is it available in a public repository, for example, indexed in Zenodo, or any other biology repository, Campbell in our case for drug data, et cetera. Is it accessible? So is this data set downloadable? It's not just a summary of the data, but the actual data is available. And is it licensed, meaning that I know how I can access it and for which use cases I can apply it to? Is it interoperable, meaning that the data set is using standard vocabularies, standard formats? For example, a CSV, a simple CSV file is actually a very interoperable format because it can be read into multiple platforms and it's very easy to operate with, and everyone knows how to, or a JSON file and similarly. And then finally, is it reusable? So is the data documented, and most importantly in the case of data, is it contextualized so that we know for which use cases we can apply it to and to which use cases we cannot apply it to, and that's very linked also to the licensing. So all these questions are now starting to be translated specifically for research software. So basically, is this research software findable? In our case, it means available in a code repository, hopefully with Git control. So in our case, it's GitHub. Also, is this repository accessible? So is it under an open source approved license, for example, the MIT license, though in our case, it's a GNU GPL version 3 license, general. And finally, is the software interoperable, meaning is it using standard data format? So our software ingests data and outputs data. So is this ingestion and outputting of data in a standard data format? Does it has a standard API, so ways to interact with the software? And finally, is it reusable? So are we documenting this? Are we versioning it so that it's really easy to apply by anyone? So you can see it's very, very similar, the FAIR principles for data and the FAIR principles for research software. And we realized this was when we started to properly develop research software, we realized how important this was. In our case, first, because we are very low resourced, right? So reusability is not only for our users, but I would say very importantly is also internal. So we started doing scientific projects independently. And then we realized that if we were much better at reusing what we had already built for our next projects, we would become much more efficient in doing science and producing impact. So first, we work in low resources, and we were very interested into this reusability aspect that we realized we were missing. Second, because we are building a quite large open source community, international, across several countries, continents, time zones. So basically, everything that contributes to make our software more fair makes it easier to grow our open source community, to onboard new contributors, new volunteers, new interns, and basically keep this community thriving and our tools improving with their support. Also, because most of our users are unexperienced, so we work a lot with experimental scientists that basically are not computer programmers. They don't traditionally use software, certainly not software that is not having a very easy to use graphical user interface. So basically everything that makes our software easier to interact with, which is very in line with the FAIR principles, makes it easier for us to implement it at active research projects in Africa, which is our main goal as a nonprofit organization. And then finally, obviously, scientific rigor. We do scientific research. So we want to ensure that the results that are obtained by using our software are basically reproducible. So every time you will use our software, you will obtain the same results. And that is also crucial for our standing as a research organization, right? So with all this, I want to highlight how our journey into FAIR4RS software was building, hopefully to encourage all of you to rethink this journey in your own research projects or organizations if you are also starting to develop software for research. So we first, let's say we started from the computational biologist standpoint of view. So we needed a reliable way to access AI models for our research. And this is when the idea of the Ersilia Model Hub came about. That was around 2020, when we were thinking how to apply our knowledge to infectious disease drug discovery. We then covered some basic needs. So of course, we knew about open source licensing. We knew a bit about testing the software, automated tests to make sure that our software was up and running. But this was basically really it until we started getting collaborators. So we had a few volunteers that were coming more from the industry world that were really product oriented. By this, I mean they started to see our research software not just as a piece of code, but as a product that we could improve, that we could maintain, that we could implement. And basically, they helped us a lot in improving the project management, the automation of workflows, the testing of the software. And this really signified like a leap for us. We continued onto these kind of collaborations, onboarding contributors at the scale, improving things like software authorship guidelines for this open source software that was having many new contributors, etc., right? So we started growing more into FAIR principles or FAIR implementation thanks to the growth of our community. And then we started to really get into the meat of it, into like properly benchmarking our tools against some of the FAIR principles by partnering with larger organizations in 2024 with Biomodels, which is a larger repository for any biological related model. So with them, we worked on standardizing the metadata available for our models using standard ontologies, annotating these models, etc., etc. And then this is also about the time where we learned about the FAIR Impact Program, which ran last year and we completed by the end of this year, which allowed us to test this F-UJI tool to improve the fairness of the Ersilia Model Hub. And I would say further than the tool itself, which we're going to discuss about now briefly, what this allowed us is to really do a deep dive into the metrics, different metrics for research software and how we could improve basically in all of them in Ersilia. But the main takes for now from this slide is that our journey into FAIR research software is obviously not a single, not the product of our effort only. On the contrary, it's really thanks to many organizations. We are just listing here a few of them that have really helped us in learning, improving, and basically adapting FAIR principles for really our use case in the Ersilia Model Hub. So it's not a lonely journey. On the contrary, it's a community-driven path. Okay, so we go to the second part of our talk, which is more focused on this F-UJI tool, which we tested and implemented at Ersilia during the FAIR Impact Action last year. So for those of you that are not familiar with F-UJI is quite a well-known tool today, which was developed to assess fairness of research data, okay? So by research data, we mean data sets, so clearly not software. So what the FAIR group was trying to do is to convert this automated assessment of FAIR data into FAIR software. There is an implementation of this FUJI software for research, where you can, instead of adding a data object here, you just put the URL of your software, and basically it will give you an automated measurement of how fair is your software. So what are the FAIR principles when we are applying to research software? Well, findable, obviously the software and its associated metadata is easy to find, and there is a number of metrics of subtopics inside the findable part. Then accessible, so it's retrievable, and there is also a number of submetrics inside that. Interoperable, so it can exchange data and metadata with other objects through standard APIs. And finally, of course, reusable, so it can be executed and then it can be maintained and basically reused for other purposes or integrated into other software, etc., etc. So these principles are quite well defined. They were published in 2022. Now the question is, how do we measure how good are we doing in each one of these subtasks in I1, I2, R1, R1.1, R1.2, right? So how do we measure how any research software is actually scoring against this? So this FUJI work team, what they did is they tried to deliver these FAIR research software metrics, FRSM, okay? I know a lot of acronyms, confusing, but basically we have a set of metrics that have a definition that are applied to one of the FAIR principles for research software that we've just seen, and that are basically divided most of the times in 3 tests, okay? So let's look at an example. In this case here, metric number 15, it says, I picked this one because I think it's quite easy to follow. So software source code license. Obviously, is the software of the source code is including licensing information for the software and also for any other external software. And why is this relevant? Because it is important that licenses are included so that we know when a software can be used and reused. So it applies to FAIR principle R1, and basically it can be measured, very simple. Is there a machine readable license file? So if we are talking about GitHub repository, do you have a license file at the root of the repository? And you can score up to 3 points. So the first point is if you have this license file in your root repository. Great, that's a 1. Another point is whether this information is included for all the components with that software. Another point is whether this license is in this internationally recognized SPDX format. So this is how you abbreviate the licenses. There is a specific way to do it. I haven't gone deeper into that, but if you go to the website, it will basically give you all the equivalents. So it may be that you are simply not using the right naming, and then it makes it more difficult to recognize the license. So you can score up to 3 points for this metric. And basically, when you run this demo of the FUJI for research software, when we were trying it out during the impact action, what you would get is this, okay, the license file is included, so that's true, you get a point. This test, so this is under development. In this case is not yet defined, so it's not yet clear how this is going to be measured in an automated way. But SPDX format recognition is already included, and then so we get a second point. So we get a total score of 2. And this is important to understand because this is really something that is under development. So the question, what we were working on during the impact action is to understand, for example, how can we create an automated measure of the licensing information for all the components in the software. So basically, this means that we need to use several use cases and understand how people is reporting this, and basically build in an automated metric that will allow us to score the maturity of of this particular metric. So that's why I want to make this note. This is still very much under development. When we first ran it, we were very depressed because we got a 9%. So we only got 9 points out of 100. And we were like, oh my God, we thought we did better. But actually, there is only 12 metrics implemented, 12 submetrics. So you can only get 12% of maximum points. So we were not doing that bad. And what we worked on, rather than just focusing on this 3% for the metrics that were really, really there, is on understanding the metrics and seeing how they would apply to our software and in which ways this should be tested for our software to pass, right? So to provide examples of how we implement some of these metrics into the Ersilia Model Hub, there is a full document on this, which is available online. I can circulate the links after. But basically, I just picked 3 metrics for today's discussion so that we don't stay here forever. So bear with me, it's only 3 of them, but to give some examples. So I picked metric 3, which is about versions of the software. Why I think this is very important in our case, because Ersilia is a highly evolving software. We use it constantly in our research and our implementation projects, and therefore we every time find a new use case, a new improvement we want to make. So it changes a lot, meaning we have a lot of versions. So this metric measures whether these versions are properly identified. So they are capturing the relation between the different versions. They have each one a unique identifier. And basically this unique identifier is available in the metadata of the model. We've gone a bit farther than that even. We've registered our software in Zenodo, so it has a DOI, but not only this, we've created an umbrella DOI. So each version, as this metric requires, will have an individual DOI, but we have an umbrella one so that all the citations can go under this umbrella one, and we collect all the citations in one place, which is also something important for research, as you all know. And now we've created a automated release. So we've decided internally, this is something that for each research software will be different. But in our case, since at the moment we are working so much and making so many changes every month, there is a new release every month. And whenever we will do a big change, we will really upgrade one number, the version, and continue with monthly releases. And this happens every month automatically, gets updated to Zenodo, gets updated to PyPy, which is and to Conda. And this is how people can access the different versions of our software. So that's metric 1. This is our Zenodo repository. You can see here the current version was published, as I said, 1st of each month, so 1st of May, and there is one version for each month that basically explains all the changes that have been done and so on. And if you can see here, you can cite all versions by using this DOI, right? So this always will resolve to the latest one and will allow us to collect all the citations in a single place. All right, metric 2. So for metric 2, I decided to show this metric number 11, actually, about open APIs. Why we thought this is important? Well, because we had been doing a lot of work with different APIs. But when it came to deploying our software online, we realized that it was not that easy. We had different versions of the models inside the Ersilia Model Hub. Some were using one API, some were using another one. This made it nearly impossible to basically build a sustainable online deployment platform. So, well, the tests are that there is a documentation on these APIs, they are open and they are machine readable. So what we have been doing in the last year, an amount of work, big amount of work, is to deprecate BentoML, which is what we were using before, and upgrade everything to something called Fast API, which is an open source standard from OpenAPI. It serializes to JSON, so basically very easily to read by a machine. It has access through a RESTful API, and this is basically how it looks like now. So now we have all the models with the same API, making it much easier to interact with, to deploy it online, to do whatever you want to do with it. And of course, this is related to the interoperability of our platform. Then finally, I picked metric number 5, which is around metadata, because as I mentioned, we did quite a bit of work with biomodels on individual model metadata, and we also wanted to improve overall the Ersilia Model Hub metadata. So metadata is any data associated to the software. It's not necessarily documentation. It's all this data that is necessary to understand basic information about the software, such as the version it is using, the dependencies it has, the authors of the software, etc., etc. Right? So this metric is basically that you have metadata in your README or somewhere else. It includes something like development status, it includes links to the documentation, and it's of course readable by a machine. So we had everything in a README file and a citation file for the authors. But what we did during this program is to basically update everything to a code meta JSON file to make it more machine readable. So just translate everything that is in the README into a code meta. And then added a development status, which we didn't have in the README file, with repo status. So now it says that it's in production, it's in development, it's ready, whatever is the status of your software. And then we have extensive documentation in Gitbook, not metadata, but documentation, which is linked thoroughly in our repository to direct people there when they have questions. So this is how our documentation looks like. There is a ton of pages here. Hopefully we are covering different use cases and people can really follow how to implement this tool locally. So this was a quick overview of the metrics we use for research software and how they are improving us to basically gain more visibility, more citations, more users, and overall more impact in research, which is what we aim to achieve. So what is next for us? We continue to work on the FAIR principles for the Ersilia Model Hub, all of them. We continue to discuss about them, see how we can improve on them, and looking at their metrics, how we can do better. We keep adding more documentation. Something that we are really into now, for example, is building authorship guidelines. So you know when you're an open source contributor, when you're an author of the software, etc., etc. And we are doing a lot of work into automating processes that help us maintain the fairness of our software and keep this a bit less challenging for a small team to basically maintain. This is a graph, an idealized graph of the Ersilia Model Hub, where it has all these components that I've mentioned. So we have an automated model submission workflow for open source contributors. We have a number of automated testing workflows based on GitHub Actions that allow us to upgrade version every time, release to PyPy, to Conda, to Docker Hub, and a whole set of workflows that are basically inspecting the models regularly, making sure that they keep working. The models themselves have their code, but also their metadata, their checkpoints, so the executable files and the specifications, dependencies, and all this is bundled into individual models. We explain thoroughly how to use these models through our documentation in the Ersilia book, but also through videos, a lot in workshops, a lot through our internship programs, etc., etc. We basically have a lot of different modules that allow us to maintain these APIs, to provide examples of how they are used. We have a CLI. We also have a Python interface. We have all the documents to make our software more findable. So README files, contributing community guidelines, licensing files, obviously. And then finally, we aim to build an open source community around it. So we try to put ways for people to basically make it easy to interact with us through GitHub mostly, and to basically work more openly, which is very linked to FAIR, though it's not on the same realm, but work very openly through project boards, issues, etc. So we do not only work on the Ersilia Model Hub, we are also trying to improve the fairness of the individual models. So things that we are thinking about is how can we use large language models for automated metadata collection on these models? How can we include more structured and standard ontologies into the metadata of our models? which is what led us to first partner with biomodels to learn more about these ontologies and how they relate to our models. And finally, how we can make these models more interoperable by converting them to a standard ONNX format. And of course, Ersilia has many other tools, not only the Ersilia Model Hub. This is our GitHub organization. We have the Ersilia Model Hub, which is this repository called Ersilia, but also a number of other repositories with associated tools that we also hope to make more fair. So take-home messages from today's talk, and I hope this was not too much, is that we are a nonprofit organization. We develop open source AI tools for drug discovery and open and global health. Everything we do is and will remain open and free for everyone. We aim to achieve the highest FAIR standards so that we can truly make our tools impactful, and we are always happy to partner, collaborate, contribute to mission-aligned projects in the open source, open science space, and infectious disease research. All this work wouldn't be possible without our amazing small team, a lot of collaborators, supporters, all our Ersilia community, and the funders that have made this work possible. So gracias. Thank you for your time. And yeah, I'm going to stop presenting so I can go back to the screen.
Thank you very much, Gemma, for a really, really interesting talk. It's great to be able to see the tool put in context of a kind of working organization as well. And I think the work that you're doing is fascinating as well. It's really interesting. But I just want to open the floor at this point to anyone who has any questions for Gemma. You're welcome to write them into the chat or to unmute yourself and put your hand up or ask your question now. If anyone does have any questions now, please do answer. We have a couple of WooClap questions as well that might kind of get some questions going as well. So yeah, if anyone does have any questions, you're welcome to ask them now.
Hello. Can you
Hi,
hear me? I have questions. Hello.
Yes,
So
we
yeah,
can hear you.
thanks very much. It's very interesting, and I'm glad to see that FAIR4RS has been tailored towards the assessment of software as well. Well, I'm basically on fever today, so my concentration is a little bit low today. So I'd like to ask you questions, but maybe these were already covered in your work, in your presentation. So I understand that you have tried to extend it together. So was this implementation done by the FAIR4RS team or by your team?
Yes, sorry, maybe I need to clarify this. So we were part of a FAIR impact action. So it's a program by the European Open Science Cloud that asked a few researchers to implement this version of the F-UJI tool that is still under development to research software to see how it did, how it scored, and how could they basically provide examples for the metrics to implement. The team that did this, the people I know are from the Software Sustainability Institute, but maybe Al has more insights into this. I think it's the FAIR team, the actual developers of this version of the FAIR tool. Am I right?
FAIR team.
Yeah, FAIR team.
Right. So,
sorry, you go ahead.
Is this extended version of FAIR available somewhere? I would be very curious.
They have an open GitHub repository. They have a fork of the original FAIR tool. Maybe if I guide you to the, let me find the actual support action so that you can have a look at everything they put there, and you will find all the documentation. So this is that one. Yes, I got it.
Cool.
There we go. I'm putting the link in the chat.
Great, thanks. And then another question is regarding the assessment, the assessment items. You mentioned that at the beginning you were a little bit surprised to see that it was only something like 9%. And then later you realized that it was because the maximum was something around 12%. Then I was a little bit lost in my mind. So was this then improved after some iterations and further development? And what
I
is
don't
the current
know.
status now?
I don't know. I haven't followed up yet with the team that were developing this, so I don't know whether they have implemented more metrics or not based on the outcome of the action. What I know, so where we left it at the end of the year is that we explained how we had implemented Fuji and how we think these metrics would work in our case, so which kind of tests would be needed. And I don't know whether they continued or not the development, honestly. I'm sorry. I should follow up with them. Yeah.
Right. Okay. Then who would be the person to talk to about further developing it?
Yeah.
Sorry, this is my last question.
I think Neil from the Software Sustainability Institute would be probably one of the best persons to talk to. So if you're really interested, I can very happily put you in contact with him.
Right, please. Yeah.
You can just write to me. That is my email. I'm also dropping.
No. Okay, I know him. So
So I think he's quite on top of this. So you can ask him anything about the specifics of this, whether it's being now actively developed or not. Yeah.
Sure. Thank you so much. Thank you.
Thanks to you.
Thank you so much. Mike, I see you got your hand up.
Yeah, I was just going to answer a couple of those points to those questions, actually. There was only two metrics that were particularly adapted for research software within the FUJI tool initially. There are some of the metrics that do match software with data, so they're the same kind of tests that would be run on a data set that would run on a software. But overall, the tool for software is not being fully developed yet and is in progress of adding further sets of tests specifically for software. So it's a little bit in progress at the moment, I think is the best way to describe it.
Well, thanks. Yeah, we'll be happy to see, to participate in future developments of it. Thanks.
Thank you very much, Mike. Nestor, I can see you've got a hand up. Welcome.
Hello, can you hear me?
Yes, we can.
Okay. Yes, thank you. I am thinking about the concept of reproducibility for the models that you have in your hub, because in my understanding, you have to consider reproducibility, but what is interesting for me is that to make sure that it's reproducible, someone has to do it independently. So someone external from your group. And then the next step, I will say, once you know that the model is reproducible, then you can think about reusing the models. And then in this context, what comes to my head is do you have any consideration in the workflow that you have there so that an external user can do this verification that the model is actually reproducible, and they can also reuse the models independently from someone outside of your research group? And that's something that comes to my head. And just also to add a little bit more of information, just because I am a data steward in the Netherlands, a software steward, sorry, and I would like also to guide young researchers in how they can provide research software that the world can reuse. Even when I was thinking about my own research, I see, okay, maybe this is kind of a challenge, right? When you think like someone else independently can reuse your work, or this feedback processing, how to do the improvement of your current contribution. Thank you.
Thank you, Nestor. That's a great question. So making a model reusable and ensuring that it's reproducible, as you say, is not exactly the same thing. So by making a model reproducible means that we should take in case that is models that we have not developed internally, we should take all the original code and make sure that we are able to not only use it, but independently reproduce, I don't know, whatever the authors report in the paper where this model is published, etc. Right? This is something that we do not do because we don't have the human capacity for it. We only include models in the hub that they are published in peer-reviewed journals, so that kind of they have gone some kind of list of check. And what we focus is on making sure that they remain reusable, because as you may know, many of these models are just dropped in a GitHub repository, never to be updated again. And most of them are they are Python-based, the dependencies just get outdated and they stop working. So we bundle them in Docker containers, basically to make Docker images that will remain stable forever, so that they will not change. And our workflows, what they do is they run these models, they compare the results and make sure that they are stable. So there is nothing that changed. There were, I don't know, changes in dependencies version that make the model crash, that basically, I don't know, descriptors are suddenly reordered and then the model is wrong. So all these more automated checks we do. What we don't do is entirely reproduce the original code from the authors. Yeah. But we'd love to find ways to do this more automated, in a way that is more automated. Yeah. Thanks for the question. I hope this answers. And then to your last point, everything we have is open on our GitHub. So if someone wants to learn more about this, I'm happy to chat more or just dive into our GitHub and open issues with questions or whatever. We are 90% of the time online and we'll answer it. So, okay.
Yeah, thank you very much.
Thanks, Nestor.
Thanks, Nestor. Have we got any other questions at this point? I'd just like to say a reminder that this session is being recorded. So we've had a slight mix-up in timings. However, this will be circulated with everyone who has registered for the event, as well as being updated on the Fair Impact website. We'll also be publishing it on the social media channels as well afterwards. So certainly people can go back and rewatch the footage, as long as access all the slides as well to continue the great work and your presentation as well, Gemma.
Thank you.
Perfect. Okay. I'll just give another moment or so if anyone does have any questions at this point. And then we are coming to time.
I have more questions.
Please.
So yeah, this is again maybe something I missed. So I understand that the extension, well, so you see that FAIR4RS follows this FAIR assessment list. So you have a list, and then of course there could be extensions, and then I'd like to see. You mentioned that only certain things were implemented, right? So where can I find this extended list, the full list, basically, for software, and then which ones exactly have been implemented?
Mm-hmm. That's a great question. Yes, I can find it. I don't have it at the tip of my hand, so I need to look for it, and then I can share the list with you, but I don't have it.
Sure, would be nice. Thank you so much.
Sure.
Mike, I can see a raised hand. Is this an answer to the question being posed?
Yeah, I'll share it later.
Thank you.
Okay,
I do
thanks.
have the list, and I do have there's a you can get it via the Fair Impact website. There is a page dedicated to the metrics for research software, and you can see the list there. And it'll also have a link through to the Zenodo-based report on this as well. So it's fully published, but if you need, I can also send you the link in a bit.
And just to confirm, this is only at the level of metadata level, right? So it's not anything to do with the implementation details. For example, the specification of the data formats that the software is exchanging. not to that level.
At the moment, it is at a metadata level. Anything else
Right.
is, even at a metadata level, a lot of it is getting quite hard to do.
Right.
So,
Okay.
which is why Gemma talked about that middle metric missing from the three. That's quite hard to go and check for all of the different dependent code bases to look for whether they all follow and have a DOI or some other persistent identifier. So there is still quite a bit of work, I guess, to be done in certain parts because they are quite challenging to actually turn those into automated metrics.
Right, I see. Thanks so much.
Okay. Thanks, Mike. I was looking for the link, but if you have it. Yeah.
Carol, welcome.
Yeah, sorry, I've arrived 45 minutes too late because I was one of the people who got the wrong time sent. But one of the reasons we wanted was because I've mobilized the eVerse network, amongst others, to come to your seminar in 2 minutes' time, and as well as the Elixir network. And we in eVerse, we will be doing a lot of the work, and we're taking over a lot of the work to do with metrics associated with software. So I just wanted to raise the fact that there's a tremendous amount of work being done in the eVerse, which is the European Virtual Institute for Research Software Excellence. It has an entire work package, which is led by Neil Chu Hong, amongst others, in this area. So those criteria and those automated criteria are very much in our remit. So that's why we're very interested. So just to let you know, it's Fair Impact is moving as well. It's also being done in the eVerse project. And Gemma, I will ask you to give a talk for us, as we all missed your talk.
I'm so sorry. I don't know. Yeah. I guess. Sorry, I didn't circulate the wrong time. I don't know.
It wasn't you. I don't think it was you. So anyway, but anyway, there'll be a lot of people trying to get on at time.
Thanks.
But Eva, I will try to get you to I will ask for you to give a talk to the eVerse team.
Perfect. Yeah, that would be not a problem. Happy to. Yeah. Thanks so much. Okay.
Yeah, apologies. I'm not quite sure what happened with the timings there, but thanks for raising that, Carol. It's good to know so that we will circulate the recording and perhaps a second opportunity to present as well, Gemma. Which is fantastic, and so glad that so many people want to hear about the next steps as well. But as we do have a few more people potentially joining us, we will continue on for another kind of 5 to 10 minutes. So if anyone does have any questions they'd like to raise at this point, please do feel free to continue that. It's been fantastic questions from many of you, as well as great answers too. So yeah, if anyone does have any further questions, you're welcome to raise them at this point. Oh, thank you, Carol.
Yeah, thank you. I'm sorry. Like people schedule things and then.
Yeah, I can't ask any questions because I didn't see the talk, so I'm a bit stuck.
Yeah, that's a good point there, Carol. We do appreciate you joining, even if it was slightly later on. But as I say, we will circulate the recording, and it does sound like there's a potential second opportunity for Gemma to present and have questions from a new group of people as well. Certainly to add to the questions that we had today as well.
Yeah. Yeah, thank you. I'll be more clear also for everyone. I put all the links.
It was you, Gemma, don't worry.
Perfect. So I guess that's it then.
Yes, so I'll add a slide around the Fidelis project. So as we mentioned, we are coming to the conclusion of the FAIR Impact project at the end of this month. We do have a second project that started in January 2024. So that is the Fidelis project. This project is a Horizon Europe initiative, and it aims to establish a European network of trustworthy digital repositories within the European Open Science Cloud. The Eden project will also work to enhance digital preservation strategies at EU and national levels. Both projects kicked off in 2025 and will run for 3 years. So still very much a lot of interesting work going on. With the conclusion of FAIR Impact, the resources and the website will continue to be present and available for anyone who would like to watch any of the previous recordings of the FAIR Implementation Workshop series. We have run a number of these over the past year. So thank you again to Gemma today for presenting a really fascinating topic as well. And it was great to again see that in the context of the FUJI tool and to hear about your own work as well. It's the first I've heard of that. So a really fascinating point there. So I'd like to say thank you to Gemma. Thank you for all those who joined us. Apologies for anyone who's just joining now. We are concluding at this point. We did circulate a wrong hour, so we are an hour ahead of some of you. However, there will be recordings that will be shared after this event on the FAIR Impact website, the same place you registered for this. We'll also be circulating those recordings as well with you all too. So thank you for joining us again, and thank you to Gemma as well.
Thank you, everyone. Have a good day. Bye-bye. Thanks for coming.